Hello viewers, I'm Kausalya. Today we are going to discuss about problem number 12, method 1. Obtain the state model of the system whose transfer function is given. Here the transfer function is given and from this transfer function we have to frame the state model. So the first step here is we are doing a cross multiplication. This term gets multiplied with y of s and this 10 gets multiplied with u of s. Okay, once multiplication is done, just we have to multiply the terms inside. S cube into y of s, 4s square into y of s, 2s into y of s and 1 into y of s. Right. After multiplying, we have to take inverse Laplace transform. So when you take inverse Laplace transform, here s cube gets modified as y is differentiated thrice. And here 4s square. Therefore 4 y is differentiated twice because of the square. And here 2s, the power is 1 here. So it is differentiated once. And here it is simply y of s and here it is y. Right. So after framing this equation, we have to select our state variables. So here the state variables are, here we are having simply y. So y is equal to x1 and next is y dot. So y dot is equal to x2 and y double dot is equal to x3. Right. So after selecting the state variables, we have to replace these state variables in the above expression. So when you replace, here we are getting an expression like this, right? Here that is y double differentiated is equal to x3. When it is triple times differentiated, then we can write y which is differentiated triple times as equal to x3 dot, that is x3 differentiated once, right? So here y triple times differentiated is replaced with x3 differentiated once plus the remaining things as such. Y double dot here equal to x3 and y dot is equal to x2 and y is equal to x1. So after writing this expression, just rearrange this expression and frame an expression for x3 dot. Right. So x3 dot is given by this expression. The next step is again the output y is equal to x1 which we had already framed. Right. So again the state equations are x1 dot equal to x2 and x2 dot equal to x3 and x3 dot we had framed an expression, right? So after framing the state equations and output equation, we have to write them in the matrix form. So when you write it in the matrix form, you see the state model is represented as x1 dot, x2 dot, x3 dot, and here we have to write with the respective coefficient values, right? So here x2 that is x1 dot is equal to x2, no x1 x3 terms, so x1 and x3 terms are 0 and in the place of x2 the coefficient of x2 is 1, right? Likewise write expression for this x2 dot as well as for this x3 dot. Right, here you see in x3 dot we have all the three values. Coefficient of x1 is minus 1, x2 is minus 2 and x3 is minus 4, which is written here, right, which gets multiplied by x1, x2 and x3 plus, and here we are having 10 times of u, that is u represents always input value, right? So in the first two expressions we don't have any u, so they are 0, and here the coefficient of u is 10 which gets multiplied by this y matrix, right? And finally the output equation is y is equal to x1. Therefore here in the place of x1 the coefficient is 1 and the remaining terms are 0 which gets multiplied by x1, x2 and x3. Right? Here comes the end of the problem. This problem is very simple. If you have any doubt, let me know in the comment section. Thank you.